thank you all for being here. For those who haven't signed in yet, can you please sign this with your first and last name, net ID, and if you're in Chemie 41 or not. Just Brad Holt just wants to know if you attended this first class. You just pass that along. It's not extra credit if you're here. Sorry, I could talk him into it, but yeah, might be a hard sell. Yeah. So I am just going to go over a brief light overview of Matlab. This is not going to take the full hour. I know I said 5:30 to 6:30. I can't imagine it taking the whole hour just because for those who RSVP'd, most of you guys have indicated that you have barely any experience with Matlab, so this is not going to go too much into the syntax. Rather, this is just going to go into some basic commands, a little bit about the IDE, and lastly, something about one of the assignments that he has assigned for you if you're in Chemie 41, particularly one command called feval that he really wanted me to go over, so I will go over that in detail, but not try to go over, not try to overcomplicate it that much. So I've done this in the past, and I think Matlab draws the ire of many people, including me, so much that I decided to make a video for chemical engineering with the help of many chemical engineering people to kind of let you guys know that you're not alone in your hatred of Matlab. So I'm just going to show that first. All right.
I honestly have a love-hate relationship with Matlab. You know, when it works beautifully, I love it, I want to use it, but when it doesn't work, I can't. I just want to throw out my computer, honestly.
I hate Matlab.
Matlab, it's okay. It's not free like Mathematica, so.
Matlab? Who am I in?
I hate Matlab.
I would rather cheer for Alabama than use Matlab. And I hate Alabama.
Do you like Matlab?
不知道，没用过。有些人说是神器，有些人说很难用，用了很久都学不会。我甚至不知道他为什么要我回答这个问题用中文。
That's enough about that. That video is a little outdated. So one of them said Mathematica is not free like Mathematica. It actually is. So Matlab is free right now. Starting this licensing period, you can actually get it free on your computer. It is the full version that includes Simulink and all the toolboxes with it. And it is compatible with all operating systems. So let me start by getting you to the IDE. So because this is going to be short, I'll leave, if you guys can leave questions at the end, that'd be great. I'll be around until like 6:45-ish if you guys have any specific questions about Matlab, or for those in 41, if you have any specific questions about feval. I'll be there to answer it for the most part. So as a disclaimer, Brad Holt wanted me to clarify I can't really go too much into like code for the assignment just because he doesn't want me to do that. Instead, he wants me to go over this specific function that you guys apparently have to use for this assignment in terms of minimizing. That being said, he didn't really give me too much about the details of this particular assignment, and he also clarified that this is also something I guess you have to use down the road for an exam or other final project. So, luck with that. Some of the things up here. Okay. So I'm going to start by just showing you the IDE that just stands for Integrated Development Environment. Is this good to see? Do we need to turn off the lights, or is this all good? People in the back? Good? Okay. Right here, when you first open it, you have the command window, which is basically the place where you can type code and prototype any commands, including ones that you wrote off of scripts by calling the name of the scripts here. Going up to the top, you have this toolbar, which includes creating files, saving files, opening up different workspaces, which I'll get to in a minute, analyzing code, setting up the layout, preferences, and even using the online reference for Matlab. The plots and apps, I won't go over this right now, but that is for installing and looking at different toolboxes. So toolboxes in Matlab are just essentially packages of code that are available from MathWorks. You don't have to think of it too much in terms of starting out, but if you're in a research lab that does like machine learning or simulations, there might be a toolbox for that you have to use directly using the interface and downloading it. So on the left side is a list of files that are available for you to either edit or create that is in the current directory. So what I mean current directory is that any command that you run or any file that you call, you have to be in a folder where it actually recognizes it. So if you're in, let's say, My Documents, let's say just talking about Windows Computer, if you're in My Documents and you want to call a file that's way up in the Downloads folder, it's going to give you an error because it says it can't find it. So what we have to do is actually either navigate to that folder so it becomes a current folder, or you add it to the path. Doing that is beyond the scope of this seminar. I will say that if you're going to dive into a lot more of MATLAB or just programming in general, just knowing where you are in time and space for programming is very important to avoid errors that can be easily fixed by navigating to the right directory. But in this case, because all the files that we have here, and because this assignment that you guys have, there's not going to be a lot of different other directories involved. Just being in the current directory and knowing that you're in the same folder as the MATLAB script you're working on is enough for you guys to get by. Okay. Something that you should also know is, so the keyboard shortcuts. One thing that unfortunately MATLAB does not do well is make the keyboard shortcuts consistent across the different operating systems. So if you want to learn more about the keyboard shortcuts, I would reference the documentation. I don't want to go over it now just because I'm on a Windows computer. If you're on a Mac, it's going to be different. And I'm not just talking about like the control key versus the command key. No, I'm talking about all the other keys too involved. It's different. And that includes Linux operating system too. So just keep that in mind. Like for example, if you want to clear the console, like I'll just write some code here. Display hello world. And after you write this, you're officially an expert in MATLAB. So there's that. If you wanted to clear the console, there's a keyboard shortcut here that's Control L, or you can also do CLC, and that will clear the space for you. It's not going to delete the variables, it's just going to clear the workspace. That's especially useful if you have like lots of output that navigate you towards the bottom of this window. Okay. If you have variables, let's say if I just create some right now, x equals 9, y equals 10, you'll notice at the bottom left, there's going to be variables listed there that you just created. Either you created manually in this command window or ones that got created when you ran a file. Those stay there for as long as you are in an active MATLAB session. When you close it, those workspace variables go away unless you save them. If you want to remove them, all of them, the command to do that is just clear. Okay. So if you do clear, you'll notice that they just disappear. Now, yes, those two commands that I just wrote, x equals 9, y equals 10, are still there. That's just showing the history of the command. That's not showing that you've ran that multiple times. That just shows that that's what you ran before. But because you did clear, that x and y variables are removed. So I just want to clarify that too. Okay, I'll do CLC. Okay. I just use the most basic command, by the way, the display. That's just basically print hello world in Python, or printf hello world in C. So I'll do this again, hello world, and then we'll print it out. So the semicolon, by the way, is to close output, meaning if you have this in a script, you want to do the semicolons. That way the command stands by itself and you won't see the output in the console. And that helps for organizing code. Like if you just want to see the display without seeing that it ran the display command, if you just want to see hello world, then you want to add the semicolon. Okay. Okay. So let's dive into conditional programming. one of the things that I was told to focus on, conditional programming. A lot of programming is just executing a task and controlling for that task to complete. One of the examples that I'll have is here right now, because we have a visual, is pizza, right? So if this pizza box was full, then you guys would come and grab it, right? The pizza. And that's already happened. So that's a real life example. And that can be translated into code. So that would be an if statement, okay? So the if statement is a way in programming to control for certain conditions if another condition is true or not. The syntax for if statements are very identical to across all programming languages. Like in Python, C, Java, and Matlab, they're all very identical. So I'll go over an example here if I click on this. This is something I've already written. I'm just giving a very generic example here in terms of statistics. In many different statistical tests, such as a p-value, or sorry, a t-test or a ANOVA, you'll get a p-value, okay? So the p-value will let you know if the test that you ran or the samples that you're exploring is statistically significant or not. This is not a stats class, so that's all I'm going to say about that. One way you could test or check if the p-value is significant is to follow the guideline. If it's less than 0.05, then the p-value is statistically significant. If not, then it is not statistically significant. Pretty simple, right? So you can design an if statement that it's pretty easy to read here, where you have the if keyword, and I'll go over what keyword means in just a bit. So the condition here is p-value is less than 0.00 or 0.05, and less than, of course, is the alligator pointing to the right. Okay, that's what I learned in second grade. So I will continue to use alligator to this day. So if that statement is true, then these two lines of code here, these two displays, display p-value statistically significant and display reject null hypothesis, that's going to run. If this is not true, then that line of code after else will run. So the else keyword is here if that if that condition in line 3 is not true. Okay, pretty simple. Again, this is a very basic example. So if I run this, and I'm going to use the run example, or the run button here, then what will print out is just what we expect. So it will have the two display lines here. Okay. And of course, if I change this, so if let's say I deliberately modify this to be greater than 0.05, if I save it, and then hit the run button, then I get the other line from line 7. Okay. So next thing is while loops. So while loops are blocks of code where you want to run a certain set of tasks while a certain condition stands true. In this very simple example, I have x equals 0, and the while condition would be while x is less than 10, you want to update x, increment it by 1, and just display the x value, and then that's it. So this is going to run. How many times do you think this block of code is going to run? If it starts at 0 and I add 1 each time, how much? Right, 10 times, right? And if I run this here, and I'm just going to clear this. If I run this here, and you'll notice that it outputs it in the command window. I'm not going to scroll up, but you get the idea. Okay. So this is one of the places where you want to be careful you avoid an infinite loop. Okay. You got to make sure that there's something inside this while loop that is going to somehow make that condition in line 3 true. Because if not, then you're going to go in an infinite loop, and you're going to have to go to Task Manager and close Matlab and rerun it and hope that Matlab still works after that. So there's a way in this code, in this example, that's going to stand true. It's going to keep increasing by 1, so eventually this statement, x is less than 10, is going to be true somehow. Okay. If you're dealing with more complicated code where you're running statistical tests, or you don't know for sure if the condition that you're running is never going to be false, then you want to have a break statement in there that says, if you're running this a certain number of times, then just break out of the code, and that will save you from going infinite for loop. Okay. Again, all very simple examples. The keywords here in MATLAB mean that you cannot use these as variable names. So you cannot use the if keyword as a variable name. You cannot use while as a variable name, or end, or return. Anything that's in blue here, or anything that you ever see in blue in the MATLAB IDE cannot be a variable name that you create by yourselves. So I can't do something like while equals 7. Okay, I can't do that. If I run it, it's going to give me an error that this is a reserved keyword in MATLAB. Okay. So the return keyword, by the way, is if you're just running a script, if you have a script full of a MATLAB code and you just want to run it chunks by chunk and not necessarily like split the code off into different files, then you can add a return statement that stops the script before you run something that you're not sure if you want to run or not. So if I had code after line 8 here, and let's say it's code that I'm not ready to run yet, I'm just kind of prototyping right now. If you add the return statement, when you run this file, it's going to stop at line 8, and that's it. And then when you're know for sure that you want to run it, you just remove it. Okay. This return keyword, by the way, is also used for functions in MATLAB, which I'll go over in a bit. And the return keyword is a very common programming syntax to end some sort of task or function, or in this case, a script. Okay. So a for loop then is So a for loop is where you want to run the same kind of operations iteratively over a certain amount. Here I have a vector in MATLAB that's basically just multiples of 3 from 3 to 30. This is, by the way, the syntax to run, or to create a vector. I'm not going to go over too much about it, because when you do your assignment, you'll know how to do it, trust me. This for loop syntax is basically you have a placeholder variable. In this case, it's I. You want to set it equal to the value that you start with up until the end. So in this case, I in this for loop will start at 1, and I at the very end of this for loop will be the length of some vector. So it's going to be, let's see if you guys can read this. If this was a numeric value, it's going to be 1 to what? What's the length of some vector? How many values are in some vector? 10. So it's going to be 1 to 10. Just think of it like that. I use the length function here. That's the built-in function in MATLAB, because you can make it applicable to other arrays that may not be the same size. So from 1 to 10, this is going to keep running the same command in line 4 10 times, right? So in this case, very simple. It's just going to display the value of some vector. So if I run this again, sorry if I hit the run button again, that's what I mean. It's going to go from 3 to 30, all referring to the values of some vector. So I want to stop here and just notify, and let you guys know about the workspace again. Notice that the variables are here after you ran these scripts. Even going back to the if statements.m, that p-value variable is still there. So it didn't clear after you ran like another script. It's still going to be there. This is where it's important to name your variables very clearly and separately. Like if you had p-value in if statements.m and you had another test script to run, let's say another t-test that you wanted to be separate from that original p-value, you better make sure you name it differently, because that's going to replace that value. And I mean, the easiest solution is just rename it or just run it again, but sometimes that can't save you. All right. And here you can also access the variables here too. Like if I wanted to just access some vector, you can use that with the command window. So if I just, for whatever reason, wanted to know the third value in some vector, I just use the syntax some vector, and this is called indexing, where I access the third value of some vector. I'm going to hit enter, and the answer is 9. So that's referring to 9 right here. Okay. Again, very basic. That's on purpose. If you already know this, That's too bad. At least you guys enjoyed pizza, right? Yeah. So the next thing that I want to go over is functions. But real quick, are there any questions so far? Yeah, we're running really fast here. So if there's any questions, let me know. Okay. So the reason why you want to have functions, or the purpose of it, is they're just reusable adaptive code that can be applied to multiple inputs or instances. That's not the same thing as a script. And let me show you an example of one. So here's an example I have here of running something that is pretty repetitive. So I'll go over the first 4 lines. You have a value called a equals 7. Line number 2 is creating a random array of 7 integers from 0 to 100. And line 3 is running a t-test. This function is built into Matlab using that array I just created. And line 4 is displaying the p-value. Okay. Now let's go to line 6. So b equals 14, and again I'm creating a random array of from values from 0 to 100. That's 14 long. I'm running a t-test again, and I'm displaying the p-value. All right. Same thing here. You guys by now should know where I'm going with this. Running basically the same thing, only this time c is equal to 21. And then again, here in this case, you pretty much see the same thing for the last 4 lines, only in this case d is equal to 28. So the purpose of a function is to kind of consolidate that, because you have very repetitive code here that you can put into a function, and not only is it more legible, but it also helps you with debugging. If something goes wrong in one of these lines and you realize that you have to modify that line, you're going to have to do it, in this case, 3 more times. And that's going to be problematic if you have a line, especially in the real world where these scripts are going to be hundreds of lines long. And I'm not kidding, they could be very long. Then you have to go to each one and modify whatever command you screwed up if you hadn't had done functions. So the example of function here is to take this 3 lines of code and make it applicable and reusable. So that's what we're going to do. So I'm just going to call this, so the keyword here is function. I'm just going to call it run t-test, and I will go over what this is in parentheses in just a minute. Just want to give a quick reminder here about copy and pasting in code. You'll have different opinions about that from different people in the domains. There's really no reason not to copy and paste if you know where your pasting is going to work. Okay, that's my opinion on it. You might hear a computer scientist say, no, you got to manually type everything out. But what happens if you have hundreds of lines of code that you want to copy and paste? No, that's ridiculous. If you ever go into a computer science course in this university, my 2 cents is you really don't have to feel like you're an amateur copying and pasting. I just did that, and I was a software engineer at OHSU. Okay. You have to define function. This is where Matlab gets a little weird. So you have to define functions at the very end of a script, and this might sound weird in terms of like the way that code should be organized from top to bottom. This will actually work. You define all the functions at the bottom, but you can run these functions before you actually define them. So the way that Matlab works is it does an initial scan for functions that are within the file. So it will see that there's a run test here before it actually runs. And then if I add another function, then it will read those too. But it wants you to define them at the bottom, so that way you can run them before they get defined. I know that doesn't make sense, but that's the way MATLAB works here. It's different in other programming languages where, like in Python, you have to define the function before you run it. Because if you, in Python, or sorry, MATLAB, if you don't do that, let's say if you do this, I'm just going to do this for you. Save it and run it. You get this error here. I get this all the time when people come up to me and ask me what's wrong with the script. And this is not that hard to read, to interpret. You just have to make the function appear, define it at the end of the line, end of the file. And that's just an unfortunate case of MATLAB's organization. But if I run it here instead, let me delete that line here. Then it would have just, it ran the function. So the function here, the only output that we get from this function is display p-value, and that's what we see at the very end. The other ones are just from the ones that are up above, so just ignore that. Okay, so that's functions in a nutshell, and the keyword here is function, and then you have to use the end keyword at the bottom here. Okay. People in 41, Chemie 41, you'll need to use functions, unfortunately. In this case, you can't have just like sequential programming. It's got to be functions. For outputs that you want to, for functions that you want to save to an output value, the syntax here is you create a variable name here as a placeholder, and let's just say this is p-value. I want to set it equal to run test. This kind of syntax is pretty unique to MATLAB. So if I want to have this output of the function saved to a variable, I just do p-val equals run test by referencing, or sorry, p-val equals p-value. And then whatever function or whatever variable name that you have equal to as the output in line 22, you have to save it somewhere within the function. So if I do this again, but I have to modify this, let's just set it equal to output equals run test, save it. I'm going to run it. I'm not going to display output. Instead, I'm just going to show you what it looks like here in the workspace. Okay. A lot of programming is just practice makes perfect. I don't have like any magical method of showing you like how to understand a programming language. It's one thing to master a programming language, but it's also another thing to master programming, period. This is just basic programming. This is not software engineering. This is not software developing. I don't think any of you would have expected to be a MATLAB master or master software engineer by the end of this seminar, because I clarified that this is a very lightweight introduction to it. So understanding output values and input values is one thing that you're just going to have to learn by continuing to try it out. Try out the code. Okay. In this case, the output value for this function that we created was just called p-val. It could have been anything. Could have been, I just arbitrarily called it p-val. And then the input here is val. That's what's in the parentheses here. That's called a function argument. So how many ever arguments that you pass into this function header, that's how many you need in order to run it. If I just define this again to include some other value, let's just call it x, and I try to run this code without adjusting it, it's going to give me an error saying that, oh wait, hold on. Oh, x is already defined. I'll ignore that. So it's going to give me an error saying that it's not enough input arguments. Okay. All right. Okay, so the very last thing I want to go over is f-eval. Okay, just show of hands, how many of you are in 41? Only 3 of you? How many people were in that class?
9.
Oh, okay, so a third. That's not bad. A third is good in baseball for batting. Yeah. So there's an assignment in 41 that you guys, Brad told me, Dr. Holt told me that you guys just received the assignment, where you have to use a minimization function that you have to iteratively use using feval. He clarified that yes, you have to use it. So he's told me in the past that students have not been able to kind of interpret feval, that they've been confused about what it actually does. It's all part of function handlers. So function handlers are one of those things where you can only give a short explanation of it. The more you try to explain it, the more confused people get. Only because when you see it being run, you'll ask yourself this one question, and you'll know what this question is by the time I run it. Okay, you have a question in your head that you're gonna ask yourself when you run it that might seem like feval is redundant, but what we have here. Hold on a second. I'm sorry. So I'm just going to show a simple example. That's the right one. So in this example, I'm just doing like a basic scenario where I have a case where it's showing customer satisfaction ratings for reputable company versus low ratings for another company, and I want to run 3 different statistical tests. Okay. So these are all built in, by the way. So one of them is doing a 2-sample t-test, that's t-test 2. Another one is a 2-way ANOVA, and another one is a multinomial logistic regression. Again, this is not a stats class, so please don't ask me to explain those. Now this is kind of going back to what I was trying to show in the nofunction.m. So this is kind of the opposite. So what kind of pattern do you see here? You notice that all 3 of these functions are different, but what is the same here? Yeah, the input arguments. The input arguments are the same. And I don't have it in this example here, but for most statistical tests that are built into Matlab, you can use graphical functions or data visualization functions the same way, and it's compatible. If I wanted to do a scatter plot here, the output for these 3 tests are going to be compatible. It's not going to give me an error because it's all built in. So that's another thing that might be similar in this case here is you're always going to run a scatter plot after each statistical test. So this is where feval comes in. So feval is something called a function handler where you are evaluating a function's outputs by not declaring it the way it's declared here. Let me go to the example. So I have the same example here, by the way. So line 12, by the way, is what we call a comment code. It's a comment in programming where you just write notes about code you run. It's very useful, especially if you like have code that you write and then a year later you forget what it actually does. That's really useful. In this case, I'm just commenting out what you would do if you didn't use feval. So line 12 is going to be, you kind of run the same thing that I have in no feval. And then line 13 here is you use feval. So notice the difference here. You're using t-test2, but it's in string, and it gives you the same output. Remember how I said there's that question you might have in your head? What's the question? Yeah, why would you use feval? Yeah, why of all things, right? In this specific example for a Chemi 41, you have to use it because in terms of what Brad Holt wants to do for grading his assignment, what you guys are going to run or write are going to have completely different function names. It's not going to be the same thing. Like one student is going to have a function name that's going to be G minimized with a capital G. One of them's going to be lowercase g, right? Because of that, he can't really grade it. The way that he has a script that automates the grading process is he can't just like know right away what the function name is. He's going to run this into a script, and it's going to like tell if the output is correct or not. That being said, what he does instead is use feval. So instead of like knowing what the function name is, he's just going to say whatever that function name is, turn it into a string, and I don't care what the string is, but just run it through feval. Then he'll see the output. I'm going to try to like explain that in a different way. So if you don't know what the function name is, let's say if you're running someone else's code, this is where feval comes in handy. if you don't know the string, or if you don't know the function name, then you could just say turn that into a string, and it will run it. So if I have test2 equal to, let's say, like some function name, like literally the variable some function name, so I'm just going to call it some function name, and let's say right off the bat you don't know what that is. So there's some code in there that Brad Holt has where he will find a way to detect what that function name is based on the script that you ran. And in this case, it could be something like, you know, at and then whatever the first function is. Okay, that's just an example. So back here in line 14, instead of just trying to like guess what it is, he'll just call it some function name. Does that make sense? Why feval needs to be used? So in your case, when you're doing the assignment, you need to use feval because you guys are going to have minimization functions that need to be iterated multiple times, where you may not necessarily know what the function name is, let's say, for using some other script that I can't really say right now because it's part of the homework and he told me not to say what the homework is, but this is where feval also comes in handy. Otherwise, don't worry about trying to understand function handlers. It is only, it's a very niche part of programming here. And in this case, this is what you have to use. And apparently you also have to use in the future too for Chem 41. Okay. Does that make sense what feval is for the three of you that are in Chem 41? For the rest of you, if you guys want to like know about it, you just ask me later. Okay. Let me do Control Z here. So I'm just going to actually run this, and actually I'll one thing I'll demonstrate too is there's also find and replace here. So I forgot to like change these into like actual meaningful variable names. So high rating will just be the name of like I'll just make up one Acme Core Corporation for high ratings. Let's see. Oh, sorry. I need to flip it. And then for low ratings, again, I'll just make one up and call it, for low customer satisfaction ratings, I'll just call it Comcast and replace all. Completely made up, right? Okay, so I'm going to run it. Let's see here. Oh, so for Nova 2, so actually can't run this because of Nova 2. There's an issue with the type that I used here in this example. But if I just run t-test2, we get the output here. Yep. Okay. So that's actually all I have. That is it. So the last thing I want to show you some resources. So Brad Holt wanted me to show like some resources for using it. So 1 second. Stop here. Okay. So the first resource that's UW related is the eScience Institute. We actually have a professor here in chemical engineering that is part of the eScience Institute, David Beck. This is a great place to know more about programming or data science in general. It's just a straight up team full of people who are just willing to help across the university, and workshops are available if you go online to this link, escience.wash.edu. You'll learn more about what's available, including seminars kind of similar to this one. Another good resource is actually in mathworks.com, the company that makes this horrible software. It has online tutorials straight from the company that actually develops Matlab and includes tutorials in Simulink. Next quarter, I think it's both the juniors and seniors. You guys will have to use Simulink down in the Unionops lab. I can't remember the course number, but you have to use it for an apparatus that is in the Unionops lab. So that it will have tutorials for that. If you want to learn more, just go to mathworks.com and then you can use the support page to learn more about it. They have actually pretty helpful tutorials. Next thing is Seattle Public Library. So this is my recommendation for you guys. If you have a Seattle Public Library card, you have access to something called lynda.com, which is a online tutorial platform for video courses, and that includes programming, graphic design, video editing. I think they have one for the ukulele that's still up on there if you want to learn more about music, but that's on there too. They have a couple of courses in Matlab, and it's very useful. For those who are visual learners like me, this is something that I've used since I think high school, because I had to learn some things in Photoshop, and it was very helpful because they have exercise files too in there. And then also they have something called Safari Books Online, which is kind of an online library full of technical books that you can read online. Again, it has all the major publishers for technical books such as O'Reilly, Pack Publishing. If you want to get a library card, it's in spl.org. And then lastly, I just want to clarify that my next seminar is going to be in 2 weeks, and it's going to be in Python. So I'm going to have a course in Python that is going to be not as like basic level as this. I'm going to try to go over some examples, working with David Beck and Jim on what examples to apply with Python. This is not going to be the only Python seminar on this quarter. There's going to be another one that's going to be on machine learning, hopefully, or data visualization that I had last year, but it's something we're figuring out. I will send more details about this to all the listservs. I'm still working with Dave Derschel, who's the Academic Services Director, to figure out the right room. Okay. Otherwise, that's all I have. So I will be here, like I said, until 6:45. So if you have any questions, just come up to me. Okay? Thank you, guys.